Hello students, welcome back. In the last lecture, we have solved examples on inverse function and theorem of inverse function. Now, in this lecture, we will be doing examples on implicit function. So first of all, we should know what do you mean by implicit functions. Is this clear? So in this video, we will be covering the definition of implicit function and some examples on implicit functions. Okay, so let's see the definition first. Definition of implicit function. We can express functions in different varieties. Okay, most of the functions we can write like y equal to f of x. That is fully depend on variable x, and it is not always possible to solve for one variable explicitly in the terms of another. Okay, so either we have to write in terms of y equal to f of x or x equal to g of y are said to be in explicit form. If an equation in x and y is given but x is not explicit function of y and y is not an explicit function of x, then either of the variable is an implicit function of another. Okay.
Now we'll
Now
see the example. Differentiate with respect to x. Cos of xy equal to x plus y. Okay. So we'll consider the equation as cos of xy equal to x plus y. We will differentiate with respect to x. So ddx of cos of xy equal to ddx of x plus y. I can write like this. Now I have to apply the derivative. So derivative of cos of xy will be minus sin xy and again the derivative of xy. Over here also derivative of x plus dy by dx. Now minus sin xy and inside I have to apply the product rule. First function derivative of second function plus second function derivative of first function. So x ddx of y plus y ddx of x, and over here it will be 1 plus dy by dx. I can write like this. Now I have to open the bracket. So I can write this as minus x sine of xy dy by dx plus again minus sine xy into y equal to 1 plus dy by dx. Alright, so I will be taking dy by dx term together and free from dy by dx term together. So I'll shift this over here. So I will be getting minus sine of x y. I can write y over here. So minus y sine x y minus 1 equal to dy by dx plus x sine of xy dy by dx. So over here I can write as minus y sine x y minus 1 is equals to 1 plus x sine x y dy by dx. So I can write this as dy by dx equal to minus 1 minus y sine xy upon 1 plus x sine xy. So this will be the answer of this question. Is this clear?
we'll solve some examples. Okay, and now from exercise set A, I think you all can solve this type of example Just you have to differentiate and write in the form of dy by dx. Alright. Next, let's see an example. If I'll consider x raised to m into y raised to n equal to x plus y raised to m plus n, then we have to prove that dy by dx equal to y by x. We have these type of examples also, and these type of examples they can ask in board for either 3 marks or 4 marks. Okay, so let's see what we can do. Over here we have got x raised to m into y raised to n as x plus y raised to m plus n, and by using this function we have to prove dy by dx equal to y by x. Okay, so let's consider x raised to m into y raised to n equal to x plus y raised to m plus n. We have to take log on both sides. Okay, so that will be log of x raised to m into y raised to n equal to log of x plus y raised to m plus n. As I told you, we can take the power to the coefficient of log. So we can write that as m log x plus n log y equal to m plus n log of x plus y. We have to differentiate it. So m is constant, I can take it out. So m ddx of log x plus n ddx of log y equal to m plus n ddx of log of x plus y. Is this clear? So derivative of log x will be 1 by x. So I have written m by x. In the same way, derivative of log y with respect to x, I can write as n upon y into dy by dx. In the same way, I can write as m plus n as it is, and log of x plus y as 1 upon x plus y, and again the derivative of x plus y. Is this clear? Now we have to differentiate it. This will be m by x plus n by y into dy by dx equal to m plus n upon x plus y into 1 plus dy by dx. Now I have to open the brackets. So I will be multiplying m plus n upon x plus y to 1 and as well as to dy by dx, that I have done. And now I have got the two terms in dy by dx and two terms free from x. Okay, so I will be taking dy by dx terms together and free from dy by dx terms together. So that will be n upon y dot dy by dx minus m plus n upon x plus y into dy by dx equal to m plus n upon x plus y minus m upon x. So I have taken dy by dx term together and free from dy by dx terms together. Over here to this step, writing brackets are very important. Is this clear? If you don't write bracket, you will not multiply m plus n upon x plus y to dy by dx. Many students make mistakes over here only. Okay, so writing brackets is very important. Fine, we'll go to next step. Then what we can do? We can take common over here dy by dx. So I can write as n upon y minus m plus n upon x plus y dy by dx equal to m plus n upon x plus y minus m upon x. So to the bracket I will be taking LCM. So LCM will be y in bracket x plus y. Over here I will be cross multiplying. So that will be n in bracket x plus y minus m plus n in bracket and then multiplied by y dy by dx equal to RHS also I will be doing the same thing, taking LCM. So LCM will be x in bracket x plus y m plus n x minus m in bracket x plus y. Now opening the brackets, we will be getting nx plus ly minus my minus ny upon y into dy by dx equal to mx plus ny minus mx minus my upon x. So over here what will cancel? What will cancel over here? So we can write nx minus my. ny will get cancelled over here, and over here to RHS mx and minus mx will get cancelled. I will be getting nx minus my. Is this clear? Now I can shift this over here to the denominator and nx minus my will get cancelled and I will be getting dy by dx equal to y by x. Is this clear? So like this you can solve the sum of these type of functions. So I am sure that exercise set B, these two questions you all can solve it very easily. Is this clear? Thank you, students.